now we'll be talking on the exponential form of complex numbers, and alongside with the logarithm of complex numbers. Now let's take a quick recap. Given z is equal to a plus bi, this is in Cartesian form, and if you have z is equals to r cos theta plus I sin theta, this is in polar form. Now, how is exponential form written? In exponential form, it is written as z is equal to r exponential I theta. Exponential I theta. Now, this works for if r is equals to z is equals to r cos theta plus I sin theta. Now, in essence, we can now equate these two, and we'll see that r is equals to r, and cos theta plus I sin theta is equals to exponential I theta. So in essence, we are saying exponential I theta is equal to cos theta plus I sin theta. Okay. Now, I won't want to bore you on how this comes about using series and the rest. However, what if we have a negative theta? Okay, what if we have a negative theta? So let's say when theta, okay, or when theta is minus theta, or perhaps we say replace theta with minus theta. So we have I exponential I, so minus theta equals to cos, wherever we see theta, we replace it with minus theta plus I sine minus theta. Now this takes us back to trigonometry, where cos minus theta is equals to cos theta, and sine minus theta is equals to minus sine theta. So in that case, we can be able to simulate this such that this will give us exponential minus I theta to be equals to cos theta minus, or let's say plus, I multiplied by minus sine theta. So this will give us exponential minus I theta is equal to cos theta minus I sine theta. Now this comes under trigonometry and also even and odd functions. Okay. Now if we now have bringing the two together, that we have exponential I theta to be equals to cos theta plus I sine theta, and exponential minus I theta is equals to cos theta minus I sine theta. We have this, and as well we have this. So with that, we can easily rewrite any form of complex number in polar form and transform it to exponential form. So let's take, for instance, we have 5, z is equals to 5 into cos theta for 60 degrees plus I sine 60 degrees. Thereafter, let's take a quick recap that if z is equals to r cos theta plus I sine theta, our z is equals to r exponential I theta. Okay. Now, therefore, So once we write this in logarithm format, we know that this is our r and this is our theta. So therefore, our z in the exponential form will be equals to 5. Following this, 5 is r exponential I 60 degrees. However, this theta here and this theta here should be in radians and not in degrees. So the next thing to do is to convert the 60 degrees to radian. So taking a bit back, we know that 360 degrees is equals to 2 pi radian. So therefore, 1 degree is equal to 2 pi divided by 360 degrees radian. So 1 degree is equals to pi more divided by 180 degrees radian. So if 1 degree is equals to pi over 180 degrees radian, then 60 degrees will be equals to 60 times pi 180 degree radian. So that will give us pi over 3 radian, because this will give us 1 and 3. Therefore, it is this degree in radian, that's pi over 3, that we will write here. So let's understand this a bit further. Given z is equals to a plus bi, which is in Cartesian form, z is equals to r cos theta plus I sin theta, which is in polar form, and here our theta is in degrees, and in exponential form our z is equals to r exponential I theta, where theta is in radian. And to convert from degrees to radian, okay, convert from degrees to radian, we multiply by pi over 180 degrees. Right. So let's take another example. For instance, we are given z is equal to 2 cos 30 degrees plus I sine 30 degrees. The first thing to do is to convert these degrees to radian. Okay, so converting 30 degrees to radian, we have 30 degrees multiplying it by pi over 180, right? So since 30 divided by 180 is going to give us 1 over 6, so we have it to be pi over 6 in radians. So therefore, our z in exponential form will be r exponential I theta, and since our r here is 2 and our theta, which is in radian, is equals to pi over 6. Okay, so r is equals to 2, our theta is pi over 6. Therefore, we say z is equals to 2 exponential I pi over 6. Let's take for instance again, we have z is equal to 4 cos 40 degrees plus I sine 40 degrees. Our R is equals to 4. Our theta in degrees is equals to 40 degrees. And our theta in radian is equals to 40 degrees multiplied by pi over 180 degrees. And that will give us 2 over 9 pi radian. Since our z is equals to r exponential I theta, we have our r to be equals to 4 exponential I, and this theta is 2 over 9 pi. Going on, we have z, assuming we have z is equals to 4 cos 40 degrees minus I sine 40 degrees. Okay, now we can notice that there's a change in sign here. It's no longer plus, but now negative. Now we go back to the beginning of the video where we have if z is equals to r cos theta plus I sine theta, our z is equal to exponential r exponential I theta. And if z is equals to r cos theta minus I sine theta, okay, because we have replaced theta now with minus theta, then our z is equals to r exponential minus I theta. Okay, so we are saying our r is equals to 4 here. Our theta in degrees is equals to 40 degrees, and our theta in radian is equal, we've calculated it here, is equals to 2 over 9 pi radian. So in essence, we are saying that our z in exponential form is equals to r exponential minus I theta because of this negative sign here. So z will be equal to r, which is 4 exponential minus I, and theta, which is 2 over 9 pi. And let's take one more example. We have z, say for instance, we have z is equals to 5 cos 30 degrees minus I sine 30 degrees. Our modulus r is equals to 5. Our theta in degrees is equal to 30 degrees, and our theta in radian is equals to 30 degrees, and we are multiplying it by pi over 180 degrees, and this in itself will give us 1 over 6, that's pi over 6 radian. Now since we are dealing with negative sign here, our exponential format is r exponential minus I theta. If it is positive, it will just be exponential I theta. So r is 5, our exponential minus I, and our theta in radian is pi over 6. Now we have been able to convert from polar form to exponential form. So if they give us a question in Cartesian form to convert to polar form, to convert to exponential form, the first thing we have to do is first to convert from polar form, and then we move into the conversion to exponential form. Okay, So now let's say, for instance, we want to evaluate the logarithm of complex numbers. Now, the logarithm of complex number is possible only in exponential format. Okay, we call that z is equals to r exponential I theta. Right? Now, if you take logarithm of both sides, or let's say logarithm to base e, that's natural logarithm of both sides. Take natural logarithm of both sides. So that means we have ln z is equal to ln r exponential I theta. Right? So let's take a quick let's recall something that in the laws of logarithm we have that log ab is equals to log a plus log b, and log a over b is equals to log a minus log b, and also log a raised to power b is equals to b log a. Now, for more understanding on indices and on logarithm, kindly refer to the video on indices and logarithm. All right. So now we can see that we can represent this as our a, and we can represent this as our b. So thereafter we have logarithm of z, natural logarithm of z is equal to, following this law, that log ab is equal to log a plus log b, and then we apply this here. We have log a, and that will give us ln a. Okay, and our a is r. That will give us ln r plus log b. That will give us ln exponential I theta. Okay, so moving on, we recall that ln is equals to logarithm to base e, right? And log e to base e. Okay, when we have same base, same power, it is equals to 1. Okay, or we say log a to base a is equals to 1. Same base, same power is equal to 1. That is why log 10 to base 10 is also equal to 1. Okay, so thereafter this will reduce to ln z is equals to ln r plus I theta plus I theta. So to evaluate the logarithm of a complex number, all we just have to do is to evaluate this with this. So let's take a question for more understanding. Given that z is equal to 3.8 exponential minus I, or let's say 3.8 exponential 2I. Now, to take the logarithm of this complex number, we take lateral logarithm. Okay, so we are evaluating ln z. Okay, so we take lateral logarithm of both sides. So this will give us ln 3.8 exponential 2I. As we have explained before, this will be our a, and this will be our b. Now, if we apply the law that log ab is equal to log a plus log b, we have that ln z is equal to lane 3.8, that's log A, plus lane exponential 2I, that is log B. Thereafter, we can now apply that log A to base E is equal to 1. So eventually this guy will reduce. So we have lane Z is equal to lane 3.8 plus 2I. So the logarithm of Z, of the complex number Z, and if we evaluate lane 3.8, we have it to be 1.3350 plus 2I. So this is our answer. So moving on, let's take another example. Let's say Z is equals to 5 exponential 0.2I. And we want to evaluate the logarithm of this. So we take the lateral logarithm of both sides. That will give us lane Z into lane 5 exponential 0.2I. Now we apply the principle of log A B is equals to log A plus log B. So thereafter we can split this. So we have lane 5 plus lane exponential 0.2I. So this will give us lane Z is equal to lane 5 plus, because these two will cancel out and we will be left with 0.2I. So in essence, if we press our lane 5 on calculator, we have that the logarithm of the complex number Z is equals to 1.609 plus 0.212I. And finally, let's take a last question on logarithm of complex number. So we have Z is equal to, or second to the last, if Z is equals to 6.42 exponential I or 1.57I, we can take the log of both sides, natural logarithm of both sides, 6.42 exponential 1.57I, and applying the first law of logarithm, that's log AB is equals to log A plus log B. Then we have lane Z is equals to lane 6.42 plus lane exponential 1.57I. So in essence, lane Z is equals to lane 6.42 plus 1.57I. So pressing lane point 42 on calculator, we have the lane Z as a complex, the natural logarithm of the complex number is 1.8594 plus 1.57I. Final question for this video, given that Z is equals to 3.8 exponential minus I, 0. Minus 0.236I. We should evaluate lane Z. Okay, so the first thing we do as usual is to take natural logarithm of both sides, and it will have 3.8 exponential minus 0.236I, and we split these according to the first law of logarithm. that says log AB is equals to log A plus log B. Thereafter, we have that lane Z is equal to lane 3.8 plus lane exponential minus 0.2365. Now, lane Z is equal to lane 3.8 plus this 2 is equivalent to log e to base e, which is equals to 1, and thereafter we are left with minus 0.26i, and when we are left with that, we'll have it to be minus 0.2636i. So lane Z is equals to lane 3.8 minus 0.236i. So lane Z is equal to is equals to 1.3350 minus 0.236i. So this brings us to the end of the video on exponential form of complex number and logarithm of complex number.